So notice that the can you still hear me? Jose? Jose, can you hear me? Maybe I can ask Digal. Digal, are you here? Digal? Oh, Digal also. Maybe I can ask Abad. Abad, are you there? Can you still hear
Yes,
me?
sir. Yes, sir.
Thank you. So I'll repeat. Thank you, Abad. Thank you so much. So that is the A sub n. I'll repeat. So as I've said, uh, I'll be discussing. Okay, so A sub n is your A multiplied by B. Okay, and now this is the part of the steel. Okay, part of the steel. Area of the steel multiplied by the yield stress. Okay, so that's understandable. Let me go back. That's your FS. Okay, that's your FS. So we kept coming back here. Why? Because we have gone through this concept already in our beam design. Okay, now let us then consider ACI code limitations. The ACI code presents the following limitations, or actually, as well as eccentrically loaded columns. The ACI code sets the strength reduction factor at 0.65. Okay, so meaning this is not the reduction factor. Okay, so this is the translation from the 0.85 is really a translation. If you can recall from our, or if you have read, okay, we may not be uh, doing it. What I'm saying is that the 0.85, do we get that? Can you recall 0.85? Because the strain should have looked like this. Okay, should have looked like this. Um, up should have looked like that. So instead that we have to do this kind of parabolic thing, we resolve that this one can be taken as 0.85. So it's not yet part of the reduction factor that we usually do for 0.90 whatever. So 0.65 for tight column and 0.75 for spiral. So the difference of 0.10 between two values shows the additional ductility of the spirally reinforced concrete. Of course, I think it's understandable. You can see this can be quite a brittle failure than this. Okay, so meaning uh, the linearity, linear. I think if you are familiar with linear and the non-linear, in terms of linearity, this one can extend a little farther than the 0.65, which is the diagonal. Now, the minimum longitudinal steel percentage is 1%, and maximum is 8%. So you only have to check your design, especially when it um, goes beyond what? Goes beyond 8%. Okay, goes beyond 8%. So try to check this one from NSCP. Where in NSCP does it say it's 8% of the gross? Okay, I would like you to please do that. Okay, and minimum reinforcement is necessary to provide resistance to bending, which may exist because of the presence of uneven load distribution in the end, at the ends of the building. Okay, so peripheral beams, for example. So I think you can imagine that. Okay, so when I say you can imagine that, of course, tributary area where they are usually located at the at the centers of the building, then they might as well have minimum moments only. Okay, so okay, so and to reduce the effect of creep and shrinkage of the concrete under sustained compressive stresses. These are very important. Okay, this is very important because you can see the building will be will be carrying that one all through its life. So I think the minimum is at least 50 years for the building. Now, my design is, I think I am uh, off the hook because it's 15 years already. So 15 years, then I think I would say I'm not going to say I am okay, but somehow, as far as code is concerned, we civil engineers um, we are responsible for the buildings that we designed for 15 years. Okay, so practically it is very difficult to fit more than 8% of the steel into the column and maintain sufficient space for concrete. I think we have discussed already uh, here. Okay, in between there. Okay, to flow between the concrete to flow between bars. At least 4 bars are required for tied circular and rectangular, and 6 bars are needed for circular. These are the minimums, okay? Minimum. If you have this, only 4, okay? At least 4 that you have to put. But you do not put any number there, any bar, so you have to design. Are we going to use 16 mm? I think that's the minimum. You have to start with 16 mm. 16, then work up to top. So for other shapes, 1 bar should be provided each corner. So for example, what if you have L? Okay, you have one corner here, one corner. So that is the requirement. Okay, every corner you have to put. The proper lateral reinforcement must be provided. For tied triangular columns, at least 3 bars are required. Bars shall not be located at distance greater than 150 millimeter. Okay, 150 millimeter on either side from a laterally supported bar. Okay, so this figure I'm referring shows the arrangement of longitudinal bars. These are the longitudinal bars in tied columns and the distribution of ties. Okay, these are the ties. The ties shown in that lines are required when the clear distance on either side from laterally supported bars exceeds 150. Mm. So I think we note here. That's what. But here, okay, I'll repeat. What does the code say? Bars shall not be located at a distance greater than 6 inches. We're talking about this one, okay? We're talking about that. But what if you have this alone, okay? That one. So the code still requires us to put ties like this if it's more than 150. Okay, is that clear to all of us? So the minimum concrete cover in column is 38 millimeter. So you have 4 bars, 6 bars, 8 bars, 10 bars, 12, 14 bars. Then I think this is necessary. Okay, why this is necessary? Because you cannot maintain you cannot maintain the what you call this the I would say the core. Okay, if this one is not, you will not put the tie. Okay, this one for seismic resistant column, so you have to put this. You have to put that. Okay, for 14 bars, I think maybe I just maybe it should have been here. Okay, it should have been there. Okay, Now 16 bars can be like this. Okay. So notice that I think that also depends. Notice that here it's just okay. Oh, okay. If you think that it's not, you still need the core to be really cohesive. You can put something like here, this one, okay, like that one. Okay, what I'm saying is that I will, but I think it becomes a problem during construction. What I'm saying is that I think we did this one last time in Myanmar. We probably right. I just have to put it on here. You can see this is the best in online. Um, That's the best in online. It's just easy for us. You can see if we're going to draw the fixed our time. So our time is very important. We are more on discussion. So what I'm saying is that we can do something like this. Can you do it? If you think that that one is not sufficient yet, okay? We call it anilyo in Tagalog. Okay? Yung mga ganito, anilyo ang tawag natin sa okay, yung mga ties na yan. Okay? Please ask questions if you have questions. Okay, so and so on and so forth. But notice that what the code would like to do for us is to really, you can see this, you can see that really the code would like us not only as book but really do something like this. This one is earthquake resistant design. So arrangement of bars, then the minimum ratio of this spiral reinforcement rows of S according to the ASI code is this one. So it must be greater than the quantity of 0.45 less the what is ACH area of core spiral column measured to the outside diameter of spiral. So minus one then F prime C divided by Fy to transverse. Now if YT, I think somebody asked me last time. It was who was that? You can recall. Sorry. Okay, my time is 2:16. Please, I'm going to check your attendance. I'm checking the attendance twice. Okay? So when 5 minutes before the end, I'm going to check again. So there are 43 of you right now, and that later. Sometimes I saw somebody having two devices. I think it's just fine. It's just fine, but you can't see this time. Only one each student. So there are 43 of us, 43 of you. But there are 59. So 59 minus 59 minus 44. So that's the number. Okay. So what I'm going to do, the final attendance that usually but that I am using is the one 5 minutes before the end of our discussion, our class. But I also check students who are here earlier. So there are only 44 earlier, but now I can see that there are two more now. But sorry for that. So I will not be able to see your name. That you are you come here on time. Okay, but it should have been 15 minutes before, but it's okay with me. It's alright. Sometimes there can be times that we have to start late. I think it's just fine, so I cannot give you the invite. Okay, but usually we always have to start on time. So it's going to be 15 minutes after that. That should have been the case that I will check your attendance, but it's alright. Okay, so now I check at 2:17 p.m. Okay, so the minimum ratio is spiral, so that's 2:1, and that the FYP, if if it's not given, I would like you to please use the main bar yield yield stress. Say for example, 413.70. Please use that. So if I indeed have different FY for that, so it must be your tie, then it is use that. So the minimum diameter of the spiral is 10 mm, and their clear spacing should not be more than 75 mm or nor less than 25 mm or 4/3 of the nominal size of the post. And the clear spacing should not be more than 75. And so there are three criteria to be used here. Slices may be provided by welding or by lapping the deformed uncoated spiral by 48 diameter of bar. So how much is that? So for example, if you are going to use 16, okay, 16 times 48. So it must have been 768, or you can say 800. 800 is your slice. Okay, do you get what I mean? Or a minimum of 25 mm. Minimum 25 mm. Mm-hmm. Provide. But 48 diameter or a minimum of 25 mm. So that's important. Anyway, maybe are you not wondering here, or it's just fine with you? Anyway, 48 bar diameter or 48 diameter of the tie of the lateral ties. And we'll have an example for this. Lap slices for plain uncoated bar or wire, 75 of the diameter of the steel of that, okay, bar wire. The same applies for epoxy coated deformed bar or wire. So the code also allows for full mechanical splices. Now, have you seen full mechanical splices? Okay. Mechanical splices looks like this. Uh-huh. I'm looking for pictures, okay? But anyway, I can draw that. It's just like the coupler, okay? It's just like the coupler. So meaning this is threaded. Here also this is threaded. So say for example, if this is your column, this is your bar at the first floor, and you want to um, splice this one. Instead of doing like that, the one that at least 48 bar diameter, we instead do this one and insert that part here, and that's why we call it mechanical coupler. Okay, so we have used this in MRT last time, but it's quite expensive. Okay, tinotorno pa to eh. So I think we got it. Some I think I think it was in Antipolo. So we went to their place and we checked how they did how they manufactured this one. Okay, because we check what material they use. So it's really nice to work in construction before you do some design, and you can learn a lot in construction. Okay, so the ties for columns must have a minimum of 10 mm to enclose longitudinal bars or 32 mm size for 12. I think I said this one already last time. Now, center to center spacing of ties shall not exceed the smallest of 48 times the tie bar diameter, 16 times the longitudinal bar, or the least dimension of the member. Say for example, if you have 400 mm by 500 mm, then what you will have is that you have to consider the 500 millimeter instead of the 600 millimeter. Now the clear spacing of ties should not be 4/3 of the nominal size of the aggregate. Usually, for normal concrete, we use 3/4 or 19 millimeter aggregate. And this is the coarse aggregate. Of course, we understand for fine aggregate that's the sun. Okay, that's the sun. The code does not give restrictions on the size of column to allow wider utilization. Of course, the code will not say you can only have as much, you can only have at least 2 meters of column, 2 meter by 2 meter. The code does not say that one. Okay? So it's up to you in terms of economy, constructability, and others, sustainability. Okay? So let's have summarized it. Columns may be tied or spirally, then you have that. So phi is equal, theta is equal to 0.65 for tied columns, and theta is equal, this is actually the phi, okay? So the phi for spirally reinforced columns. Then rho g must be less than 8%, and of course must be greater than 1%. When we do this, you also have to check the rho minimum. Okay, but checking the rho minimum, you can just say, okay, it should have not been 0.01%. Okay, so minimum ratio of spirals is this one. You just have to use that, right? So when this one is given, then you can do that. So where h sub s, area of spiral reinforcement, b sub ch, diameter of the core measured to the outside diameter of spiral. So, diameter of the column, diameter of the core measured to the outside diameter. Oh, measured to the outside diameter of spiral. So meaning it's not within. Okay. Yeah, I think it's conservative. Do you get this one? Diameter of the core measured to the outside diameter of the spiral. So what does it mean? Because the spiral is like that, and when you pour it, the core, if you can imagine, the core which includes the volume of the concrete within the spiral, and that is why the code says it should have been within to the outside diameter of the spiral. So when you wind that, and the ties, of course, if you can imagine it, it's up to the, of course, up to the part. That's why it says it. So it's not in the interior. It's not in the interior of the spiral, or even because the spiral okay, it has or it clasps the vertical bars. It's not even within the boundaries of the longitudinal bars. It must have been outside of the spiral. The diameter of the spiral, then b sub s diameter, then the minimum diameter of the spiral is 10 mm, b sub s spacing 75 or less than 25. Not be more than 75 or less. Okay. Factored loads per tied columns. So this is it. Okay. PU is equal to P sub n in this context, but PU should be greater than, should be less than or equal to P sub n. It is always nothing. But of course, when you have to determine this, for example, and that is your 0.65, is that right? That phi is 0.65. You have to equate these equations, okay? That equation, so that you'll be able to get either a sub g or a sub st. So you can play with this, especially if this one is given in the problem. Did you see it? Can you understand what I'm talking? Alright. If you don't answer, then he said you are okay. I hope. Okay, so we will go fast. We have one more hour, so we will have to discuss four examples. So, or piece of view 0.80. What's the difference here? Did I make some difference? Okay. Notice that the difference here is that um, what if this one is given? Then you can readily do this because this one can be given, and if times is given, I think you're done doing this one. Right? So you just try to analyze that. Okay, so it's easy. Why? Because AG is your B multiplied by S. Really, for example, if the B is the width of the column and H is the height of the column. That's the geometry of the column, the section. Okay, in terms of the height between the floors, but I'm talking about the height of the geometry or the section. Okay, so where you can see where phi is equal to 0.6. Now for spiral, again, you can see they're just the same. They are just the same. Just the same. But what about the phi? The phi is 0.75. And don't forget this. Okay. Now for actual tension, you have your T sub u is equal to phi multiplied by A sub s divided by 5, where phi is your 0.90. Now, there can be tension columns. Okay. Notice that when you do your design, there can be times that some of your columns can be in tension. Okay, some of your columns may be in tension. And so when that is the case, so you have to use this. So example. Let's do that one later. Anyway, that's there. So I think I have a different. It's not the same example. So it's just there. So, okay, let's do this. I will write it, okay, for a while.
Next month, ako din na lang. Hindi bayaran na. Itong buong buwan, mabayaran mo ng mga pro. Ikaw muna.
So let me write it so that we can have a new one, okay?
Anak niya, at talaga abnormal ang akala ko kasi.
Mag-isikan na natin sila.
Oo.
Talking with our microphone.
Pabili nga. Ciao.
Ay,
Nabili.
Doro?
Oo.
Wala?
Oo.
Wala mo.
Wala ba dito? Wala ba dito?
Down.
Okay, so let's have this problem. Design a rectangular type column to carry a backward axial load of 175 kilonewtons. Use F prime C is equal to 30 megapascals, Fy 400 megapascals, and a steel ratio of about 2%. So let me just do the given. So let's put that one, okay? But when you are doing it, you can choose not to put this one, no? Then what else? What did I say? Design a rectangular type. I think there's something here. Okay, design a rectangular. Ah, there's another more. 2% Fy. Then this one is given. Okay, this one is given. So B, which is the column width, is equal to 300 mm. Okay, so B is equal to 300 and piece of view 1765. Okay. 1765 kilonewtons. And you can see when you write the given, sometimes it can help you review what's given in the problem. I think that's the purpose of writing down the given of the problem. So it's 10765 kilonewtons, and rho this time is given. But there can be times that this one is not given, so you have to resolve using the interaction diagram. So I think we have to make this one faster so that I can show you how to do that. Alright, so what's the required? Required is this one can be h. Okay, so the least dimension, you should call that one b, that is equal to 300 mm. And you just have to write something like this. Because that is your ties. That's your tie. Okay, so I think, can you solve it now? So using number 3, so what are we going to determine? So I'm looking at we would like to get the AG. Okay, solve for the AG. Okay, whether this one is given or not, then you have to solve for area gross. Okay, so using, just make this one Just equal to Can you follow? Anyway, you don't have to write because later I'll just have to, I'll just put this one in our canvas, okay? I'll just, I'll make this one as PDF. I'll put this one in canvas, okay? You have to tell me. Then let us say that this one must be greater than or equal to p sub u, and m sub n must be greater than of m sub u. Then I say 1765 multiplied by 1000 is equal to I think it would be harder. Could be harder for that. Okay. I put that one, okay, as a preliminary, okay. I just put that one, okay, because we can be thinking this way, okay. We can be thinking this way, and when you are there, I just actually mimic what other students or me as a student can think during the time that I am solving this problem. So without any um, without cleaning the one that I presented to you, I just would like to share. That's how I think earlier. Okay? Then I'm thinking if that is okay. If the gross steel ratio is rho g, okay. If the gross, then later we will clean this up. If the gross steel ratio is rho g is equal to AST. I think I've shown that one earlier, okay? Then substituting one. Where is that? This one is 1. This one is equation 1. Substituting 1. Substituting 1. Then it's equal to 0.80 P, 0.85, then AG minus AST plus FY, then rho G, then AG. I just derived the equation, okay? Then phi sub n is equal to 0.80 times phi, then 0.85 F prime C AG minus 0.85 F prime C rho G AG plus FY rho G and AG. Then I will be cancel some terms.
Okay.
Then, but I could be amount, okay? Could be amount here. Okay. It could be amount 0.85 of feet, then AG 0.85 F prime C plus rho G. I think we have this one already. Did we have 0.85? It's just a derivation so that you can see how it's. Then piece of n, I think this one is clear already. Piece of n 0.80, and I can see. Okay. Then I will say now, we will say now, piece of n is equal to 0.80 phi area gross multiplied quantity of 0.85 f prime c plus rho g fy minus 0.85 f prime c. It's the same. So rho g is equal to 0.002 and substitute, of course, in that equation. Can you follow? So 1765 times 1000 is equal to 0.85 multiplied by 0.65, then times AG, then 0.85 of how much is the F prime C? 30. 30. A 30 plus 0.02 times, how much is that? Equal 4. Right. So it must have been 400. You have to, please look at my solution, okay? 0.85 times 30, then AG is equal to 1765 times 1000. Then 0.80 times 0.65 times 32.99. So after everything, so that one is equal to after everything. So it's equal to 102. 887 m squared. So when B is equal to 300, so you substitute that one, then H is equal to 340 feet. So we say it in terms of 50 millimeter interval, okay? 50 millimeter interval, so we have to use here, say, 350.
Pahina mo. Pag dito pahina yan. Kasi nag-i-scroll ako.
Now, let us check. What have we done so far?
Oh, sa labas
I
ka.
just want to 0.18. I think somebody must have asked questions. Okay. So AG now, that's the AG, okay? That's the AG actual, okay? Now AG design, of course, you are going to assume a 300 by 350 mm. So if you are going to multiply that, of course, that becomes 300 by 350 is equal to 105,000 mm squared. So design reinforcement. So let's number 5, is that correct? So this number 3, then solve for AST. No, it's number 3, and let's go to number 4. So let's go back then. So that's our equation, okay? Now when we have this part of that, does it make what we have done so far is that we want to achieve this. We want to know that, okay? What if we are going to use this? Would it be harder? Yes, because there are two variables. Now notice that the variable here is only a sub g, so it's only the area gross. That's the intent of the solution. Okay, so we cannot do two things at the same time, like solving for the area of steel. So we have to do first the area of the gross area of the of the column based on the given. Now, the equation above contains two variables, and we cannot solve that. And if you can see, if we are going to do that, we can do two simultaneous equations, and maybe that will take us long. So we can only represent, I would say, represent one of these as a relational variable, so that you can take out a sub st. Okay, that this part. Okay, that part ast. Did you get that? So what I'm saying is that when you solve, like, actually I have given this one as I have given this problem, but nobody out of 65 before, nobody got it. So I am giving it now. So what I'm saying is that in solving the problem, you are given by the code with equations, formula. So you have to look at the equations and the formula that are present, so that you will be able to represent one variable in terms of the other. So instead of solving two simultaneous equations, which can be a dead end, I think it's nice to use that. It can become a quadra a you can be using Newton-Raphson method if you are going to do that. So you have to have variables. Now the code really help us doing it, because the moment rho g is not given, then you have to resort to interaction diagram. Okay, so the code will tell us how we can do these things. Okay, but you only have to go beyond what is in the what are those in the equation that you can facilitate and use, so that you'll be able to solve the problem. So I'll repeat, the equation that we have here, it's basically is basically in terms of this one, and you have two variables here, a sub g and a sub st. So we're looking at giving you, anyway, you can just read this. Okay, I do not know if this one is the same. I just read it. Okay, sign is circular column, but what I did is that it's a rectangular. Okay, so I'll repeat. the example that I'm just giving, we're almost done here, and I'm going to give you an interaction, another example, so that you can, this one can help you during our quiz. So check, if you have that equation, then of course you will be thinking how you can eliminate one variable by representing this one in terms of that variable. Okay, we can solve this in terms of um, two simultaneous equations, but maybe you will be getting imparted. Okay, and that can be a problem. So we can also use this. Okay, we can also use that. So it's identical here. So rho g is equal to AST. Okay, so I hope you got I hope you got the structure of the computation anyway. So this one is the design. This is your first, okay. This is your first iteration, okay. It can be that the first cannot be okay, so you have to watch out for that. Okay, you have to watch out for that. Okay, so I hope you understand what I'm doing. Okay, what we are doing rather. So here, okay, I can be a typical uh, a problem solver where I go directly doing this. Okay, doing that. But notice that here I can be thinking more. I think it's not possible. So when that is not possible, then you can do other potential uh, way to solve the problem. So let's have number five is the number five. Number five is solve for the
Hindi man sila, pero hindi dapat ipagsawalang bahala.
solve for AST. Solve for AST. So that's the reinforcement. So AST is equal to 0.024. I would like to say, let's put the equation. I think that can reinforce our mind. Okay. So I would like to put rho is equal to BD, is that right? BH, or that's equal to rho multiplied by AG. It is equal to, this one is given, 0.02 times 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 um, we're going to use here we're going to use here the AG actual. Okay, let us use AG actual. 102,887, and that is equal to, does it make sense? What do you think? Does it make sense? 2057.74 m squared. Okay, and say for example, our problem is not yet done because you have your AG and you have your AST. You need to do the details for this. Okay, you need to do the details. So using, say for example, using 25 box, where area 25 is equal to 5 over 4, and 25 squared is equal to 490.87. So we want to know how many number of bars. So 2057.74 divided by 40 is equal to 4.19. Say, how many bars? Can you say 5? I think no, because I think you need to have a balanced number of bars on the other side and on the opposite side. So you can say 6, he says. Okay. Now notice that if you are going to use that, maybe we can have more than this. Okay, maybe we can have more than this, or simply just equal. It might be too conservative, but what is needed is that if you have the area gross, or if you have the rho g gross, so you do that one uh, with area gross also. So let us check area AS provided. I think, and then we check. Okay, let's do this. So AS provided. Of course, is equal to 490.87 multiplied by 6 because there are 6. So it's equal to 2954.22. Don't forget the unit. So let's try using okay. Use 22 millimeters bars. Okay. So area 22 is equal to how much is that? 380. 380.13 and squared. Okay. Can you sense what I'm doing? Then 2057.
Po.
Yes, dakanan.
Si Padolina Patrick po, sir, na lumabas na wala po sa kanya po yung content, sir. Hindi daw po siya makapasok ulit.
How can you do that? I think there's something wrong with the there is something wrong with this network. Any more question? It's all right. Okay. Now, what obvious please? Question.
Sir, correction lang po dun sa ES provided po. 2945.24 po kasi yung na-compute sa sir. Sorry po.
Okay. This one?
Opo.
Okay. Thank you.
Si Kane.
It's good. Thank you. It's nice. Okay, thank you so much. Notice that. So how much of 2057?
Diba?
2057. You know, this problem, I did not do this one straightforward. I am using what ifs. Okay, what ifs, because I know you are going to do your manual or design report. What if you are going to use 25 mm because that's what in your mind. That is what in your mind. Okay, so what we are doing right now is that we simulate. Okay, we simulate. That's the same thing if you are going to do a calculation for the design report that I'm telling you. You have to do this. I hope that you're going. But I hope it's a record. Okay, what I'm saying, I hope that you are doing it right now because you will be able to do practice. Okay, because when
Sabi
you
ko,
do it
maingay dito.
lastly, di mo na siya mani, di mo na ma-appreciate eh. Tapos na yung laban eh, di ba? Sabi nga, aanin pa yung damo kung patay na yung kabayo, di ba? Parang ganun din, aanin mo pa yung paano ka practice na patapos na. Pero kung ang pinag-usapan ay, anyway, mag-take ka pa rin ng mga finance. Pero kung magsasubmit tayo ng third week ng design report, third week ng modular group 3, parang gahon na rin yung oras na para gagawin mo yung iyong mga ito na manual calculation para doon sa iyong sa required natin na gagawin. Yung manual calculation, sabi natin, ay, of course, gawin mo muna sir yung ganito para makita ko yung flow, saka mo po siya ilagay sa spreadsheet. Kahit isang ganito lang kada problema para makita natin. Madali lang naman to sa Excel eh. Di ba? Madali lang. But the flow of the Excel cannot be seen also because I don't like to go every cell. How did you do that? But of course, I'm checking maybe perhaps you did not create a continuous uh, design. Okay, for example, it's just very easy because you make this one in part of the cell and you just call it later. It's very easy. Okay, very easy for the when you want to automate this one and you put macro. I think that's something that's good. Okay, so that's something that's commercial. Okay, commercial programs. But if you can do that, to me it's alright. Anyway, you're going to submit to me your Excel file. So what I'm saying this time is that I we are trying to simulate, okay, by getting first 380. Is that correct? Yeah, 380.13. Okay, and that would amount to 5.41. Then say 6. 6 din ang kailangan mo. So, anong gagamitin mo? Is it 22 or 25? Yun ang ibig kong sabihin. Okay? So, that's why I show that. Okay? So, 6 pieces din naman kailangan mo. Okay? So, AS provided. Sulat lang, sir. Okay? 380.13 multiplied by 6. Nakapasok na ba si Padulina? Sorry, Padulina, hindi ko rin alam kung paano nangyayari yun So, 2,280.78 mm squared. So, still greater than, where is that greater than? 205s. Oh, no. Okay. Less than 2057. So, that's okay. So, no. The requirement is 2057, okay? 2057. But you can see is still that is 2280. And we can say that that is greater than AS required. Okay, AS required earlier, which is equal to 2057.74. Okay, and squared. So we can say it's okay. So in this illustration, you can try 20 millimeter kung po pwede pa. Kasi 2057 to eh. But what we are trying to do here is that we are talking about economy. Okay, we're talking about economy. And sometimes, as I've said, you can be I think not so much, okay? Not so much on that, I think. I think ito lang yung pinag-usapan masyado. Okay? You just see to it that the FY pareho lang. Wag nang ibahin wag 40 isa. Okay, kumarin ko nun. Okay? So, how do we end this part, this solve for AS? You have to say, therefore, use 622 mm bars. Okay. Now, number 6. Okay. So once we're done with that, let us check the strength of the section. Okay. So check number 6. Number 6, is that right? Oh, no. Yes, number 6 is check the axial load. Okay, check the axial load strength of the section. You always have to do this, okay? Of this section. Make it your, so you have to practice doing it, okay? So P is equal to 0.80, then P, then 0.85 of prime C AG minus area of steel plus area of steel multiplied by its yield. A yield stress. Then you can now say 0.80 is equal to 0.65 times 0.85 times 30. Okay? Times 105. 105? 105 ba? Yes. Tignan mo dito ha, huwag kang malito dito ha. 105,000 yung ginamit natin, yung kasama. Ito yung design AG minus 2280.78, then plus 2280.78 multiplied by 400. Of course, you do the bracket there. Hindi okay tignan. Erase natin. Kahit. Alright, so let us, of course, divide it by 1,000 so that we can end up having a kilonewton. So if you do that, this one is equal to 1863.46 kilonewtons. Okay? Now that is greater than P sub U is equal to 1765 kilonewtons. Okay, so you will say, okay, what will happen if this one is you're going to use AESD is equal to 20? Aabot ba tayo dito? Nalagpasan ba natin? That's a good question. Okay, if you will ask question, but I would like you to do that. Okay, I would like you to check that. Let us do the design of the ties. Okay, tapos na tayo. We're done already with the red bar, with the main bar or longitudinal rebars, and we're also done with the geometry. Now let us design the ties. Okay, design of ties. Design of ties. So use, of course, we only have 22 mm. Of course, you have to use this. Not the 12, not the 12. If you use 12, of course, you are wrong. Okay? Right away, all of the computations that we will put underneath will be wrong. So spacing is R. 16 D sub D is equal to 16 multiplied by 22. That is your bar, okay? Rebar. So that is 352 mm. And you have number 2. You have to check your 48 of this, which is your 10 mm rebar. Okay, 48. Then your 10. That is 480 mm. Then 3, you have your least dimension of the column. Okay, so least dimension of the column. So you have 300. That is the one given. So this one is great, is big, and of course this one will govern. Okay, governs. One governs. So note. I just put this note. Okay. I just want to reiterate it here although you know that one already because we have discussed it. I'll just put that one here. Clear spacing. Clear spacing is different from center to center, of course. Okay, I just want you to note that maybe you can, if you can, uh, you know, of clear spacing of dice should be at least should be at least 4/3 4/3 of the nominal nominal size of the aggregate. Of the aggregate, say 3/4, or that is equal to 19 mm, as I said earlier. So let us check then. Okay, so let us check then. Let us check then. Okay. Let us check. So how do we check? Let us draw that. So these are your bars. This is your bar. Okay, and let's let it be that this is your ties. Okay, let it be that this is your ties. So what we check this, okay? So 4/3 of 19 mm is equal to 25. That's wrong. Okay, that's wrong. That's wrong. Should look like this. Clear spacing. Clear spacing. The 4/3 of 19 mm is equal to 25.33 mm. Okay, just to show to you the note. Okay, of course, it's great. 300 mm is greater than that. So we will say therefore 300 mm is okay. Is okay. Okay. Now, this spacing is center to center. Is that correct? But what is described here is that it's 4/3. Okay, clear. But even if you're going to, you try to check if that is 300. Okay, minus, if that is 22, half of that multiplied by 2 is still you have 200 something. All right, so I hope you understand that. Then the last is that details. You have to draw this, okay? Now I would like you to note, because anyway, this is a discussion, and notice that we almost, this is a discussion, as I said. Kaya na lang mag-adjust. So what do we have? Oops. So now we can draw. You have to put sides first, then of course this one is the longest. Put the other one here. Okay, so this one is your, how much is that? 350, am I correct? And the other one is 300. In that you will say this one is 10 mm ice. 300. Then you will say then that you have your 622 mm vertical bars. Okay, so that's the end. All right. Any question? Any question? Do you have questions? So that's how I would like you to do your design in during our assessment so that it's clear, and also when you are doing you to submit the first in your appendix, or whether you can put that one in your chapter 3 for the design of the columns. Okay, now this is one. Okay, this is just one. Now let's have another more. Okay, let's have another more. Okay, next is that we have 10 minutes more. Okay, let's have another example. Okay, now this example is considering p plus n. Okay? P plus n. Earlier we only have p. Alright. If not done, if not finished, then I would like you to finish it. But I would like to start it because okay, so let's have I have prepared 4 problems for you. Okay. Mm-hmm. Okay. Let's do that. Okay.
Ma,
Alright.
sinong patay kila
So
Jessica?
I will just draw right away.
Sinong patay
what I
kila
would like
Jessica?
to share.
Sinong patay kila Jessica?
You have
Hindi ko nakalaman. Hindi mo taga dito.
500 by
Jessica lang sa kasi mag-anak ko.
500. All dimensions are in milliliter. Okay, when I will not say it's but anyway, I'm going to put that in there. Okay. So this one is 300. And let's put another one. Okay, and let's have
Ano? Ang sige. Bangatang kita.
Tataka.
What I'm doing right now is that I'm considering p plus n. Never mind the spacing, okay, but it's 65 still. Okay, so 500, 300, so this one can be this one can be, let me label it as cross section, and this one is our strain diagram. Yeah, and this one is our stress and forces.
Sir, question po.
Yeah, please.
Sir, yung 65 mm po ba, dun po sa centroid yun ng steel o dun sa stirrup, so sa end ng stirrup?
Centroid.
Okay po. Thank you po.
Centroid. It's a good question. Okay, that's a very good question. It's a centroid of the the 65. Okay, 65. 65 mm. Okay, and that is okay. I'm putting there 24. Okay, for a while. I'll just it's 430. You have 430 mm. There are vertical bars. Vertical bars. Then 65, cross section 300, h over 2. All right. I think it's complete. Okay. So solution, okay, solution. I may not be talking so much about the principles and the concepts. I just would like you to please go back to here. I'll show it to you. Okay, I'll show it to you. I'll show it to you. But this one is these are very good problems. I'll show it to you. So I just got it here. Okay, so we are now here. Okay, we are now here. Okay, we are now here. I just would like you to please go through here because this is the examples. This is the example that I am looking at. Okay, this is the example that I'm looking at. And how we can draw this. Okay, how we can draw that. Not so much time. Okay, I'll just give you this one as part of your assignment. Only one. I'm thinking about this one later. Okay. The design of short columns. Okay, interaction diagram. Okay. We don't have much time. So any question? Any question? Now, the 1 minute, I would like to ask you to do this for yourself, okay? Because design the type column, you have the interaction diagram for 11-1, and please do that. There's an iteration here. We do the iteration supposedly for the one that I'm going to discuss to you, but we don't have that much time. But anyway, you can do this, okay? Right up to loaded column, and I would like you to submit this one to me. Uh, that is as part of your exercise. Okay, I think you will not be, you cannot, maybe you will not be doing this one if I'm not going to tell you. Okay, this is your assignment. All right, I think these are just pieces. I would like you to go here. Okay, let me check my solution. Okay. Anyway, I just have to post this one within the day. Okay, same as the one that I'm going to supposedly finish, but I would like to just this one. Okay,
Ang bukas na pares
just
tayo.
this one. The same thing that I would like to do, I just have to make this one as well. Thank
Pares na
you.
tayo rainbow eh.
Okay, do you have questions?
Ay, ano, princess.
Any questions?
Bukas. Mamaya na, ano
If
ba
not,
ito? Napakalikot naman.
So if none, there are 49 of us now. So I'll just check later. 48. I'll just have later. 4 students came in. Okay. So 1, 2, 3. Okay. So thank you so much for coming.
Ay, mama, joker ah. Joker? Joker. Joker.
Mukha kang joker eh.
Joker kanto.
Pinagbigay ka sa joker eh.
Mama, pinabag kami joker. Oh, may kanto.